Hello everyone, welcome to our channel Kick the Problem. I'm your one and only Shivam back again with a new video on a matrix. Today we are going to solve a problem in which we are going to rotate the given matrix by 90 degree. So you can see over here we will be given a 2D array, that is a matrix of size n cross n, that is it is a square matrix. We have to rotate it by 90 degree in anti-clockwise direction without using any extra space. We cannot use any extra space. So this is given input and output. We can use time complexity of order of n square. So guys, if you are new to our channel, please do like and subscribe our channel so that you get notified whenever we upload our video in future. So guys, let's see the solution of this problem. So guys, you can see this is the same example from the question. Like if you see your first row 1 2 3, it is rotated anti-clockwise. So 1 2 3 is over here, and then after 4 5 6, 4 is here, 5, then 6. In the same way 7 8 9, it is rotated again anti-clockwise. So the solution of this problem I have divided into two parts. First of all, I am going to transpose the matrix, given matrix, and then after second step I will traverse each column of transposed matrix, and then after I will reverse the elements. So you can see here, let's example, this is our given matrix. After transposing, you know that we are going to get this, like rows will be changed into column. You can see here, this is our row and it is changed into column 1 2 3 4. The same way 5 6 7 8, this change into column. All the elements which are in the row has been changed into column. After that, in second step, what I will do, I will traverse each column. Like I will traverse this column, then after this, then after this, and then this. Now after traversal, we have to reverse the element. So while doing reversal, what I will do is I will swap first element with last element in the given in a column, and then after I will swap second element with third element. In the same way I will do for each column, and then after we'll get our required answer. So for a while I'm erasing this. So guys, you can see this, this is what solution every student used to write, but they will do a little bit mistake. What they will do here, for int I is equals to 0, for I less than max matrix dot length, that means size of row, and I plus plus, and same way for column it will do, they will start j is equals to 0 and they will traverse. And what they will do, they will swap for each element, like ijth element they will swap with jith element. Like diagonal elements they have to keep as it is, and just they have to swap, like they have to swap this element with this. In the same way this element with this, diagonal elements will remain same. In the same way this with this, 8 with 14, 4 with 13, this with this. These elements are going to be swapped and we'll get transpose of our given matrix. But in this code there is a problem. What it is, let's see by doing a dry run. Like first of all, it will traverse for first row and it will swap the element. Again it will traverse for second row, it will swap the element. For third row, traverse, swap the elements. Again for fourth row, it will swap the elements. So in the traversal of first row, what it will do, ijth element it will swap with jith element. So 0 0, if we change swap ij, it will remain as it is. So this element no need to swap. Now here what is the index of this? It is 0 comma 1, so it will be exchanged with 1 comma 0, that is 5. So 1 will remain as it is. I will write first diagonal element. 6 will remain as it is, 11 will remain as it is, and 16 will remain as it is. 5 will come over here and 2 will come over here. Now 2 is done. Now it will, pointer will come to here, and 0 comma 3 will swap with 3 comma 0. So 3 will come over here and 9 will be over here. Now pointer will come to 0 comma 4. 0 comma 4 is swapped with 4 comma 0. 13 will come here and 4 will come here. Now first row is done. Now traverse pointer will come to second row. Now again ijth element means what is this, 1 comma 0 should be swapped with 0 comma 1. Now if we swap 1 comma 0 with 0 comma 1, again this 2 will be replaced with 5 and 5 will be replaced with 2. So are we going to get transpose? No, in this case we are not going to get transpose. We'll get a something else answer than our transpose. So what we can do is, the thing you have to consider is, whenever you are going to do transpose, either you traverse for this element or you can traverse for lower triangular, either for upper triangular or for lower triangular, and you can swap with respective, like ijth element we can swap with jith element. So what I will do is, first of all, like simply like I will make here a small change. I will write j is equals to 0, I will change it to j is equals to I. Now what it will happen, it will happen like for first row it will remain same as it is, like it was traversal done in last method. When it will come, pointer will come point to this second index. It will not start from here, it will start traversal from here. Again in third, it is like when it will come to third row, the iteration will start from here in the same way from here. So it will not affect in the transpose of our matrix, and we'll get a proper transpose of a matrix. So this thing you should remember. After doing transpose, what we have to do is we have to traverse each column and we have to swap the elements, like 1 should be swapped with 4. So for that, what I've done is I have taken a for loop. For what? For traversal of this column. Simply I have written upper index to 0 because it is like, if we simply think this is only a one array, I have mentioned it as 0 and mentioned this as matrix of I dot length minus 1, because this is a square matrix, row and column are same. So for each column I have to run this matrix. So I have used a for loop, and I have given a while condition for, like first of all we'll exchange this and this. Upper index will be here, down index will be here, 4 will come here, 1 will come here, and then after pointer will upper index will increase. You can see I have done upper index plus with and lower index minus minus. Upper index will point to here, lower index will point to here. Again it will swap the elements. After that, again upper index will increase its counter and come over here, down index will decrease its counter and go to 2. Now in this case upper index will become less than upper index will become greater than down index. So at that time our while loop is gonna stop, and then after it will go to the second column. In the same way it will run for these elements, it will swap the elements and it will reverse the elements. So guys, this is the procedure. First of all I will do transpose of a matrix, and then after I will reverse the elements. The time complexity of this approach is order of n square, because I have used a nested loops over here. Here is also one nested loop, while loop inside for loop, and here is one nested for loop. And space complexity is order of 1 because I haven't used any extra space as it was mentioned in the question only. So guys, you can see this is our code. Both for loops I have written over here, one for transpose of a matrix, another one is for reverse of a give each column. So guys, let's compile our code. You can see it is running for first example, that is first test case, and the output is same, 369, 258 and 147. Let's submit our code. You can see our code is successfully submitted. So guys, if you like this video, please do like and subscribe our channel and press the bell icon so that you get notified whenever we upload our video in future. Till then, keep enjoying and keep watching Kick the Problem. Bye bye.